Well, hello there. Well, you can't see my face, can you? Hold up. Let me turn my lights on. Let me turn my lights on so you can see my face. Well, it doesn't really matter that you can't see my face. But anyway, I'm going to leave here in a second to go get my coffee. I just made myself a cup of coffee, and I need to go get it. So just give me a second, and I'll be right back. Don't go anywhere. I'll be right back. I have to go grab my coffee. Okay, I'm back. All right. Let's see here. I'm just going to double check and make sure you can hear me. All right, so let's see. So this project is a project I've been working on for like quite some time now. I was working on it before the whole coronavirus thing happened, and then the coronavirus thing happened, so I kind of took a break and focused on other things. But today I'm back, and I believe we got to the point in this project where we just needed to start creating the model. But I also wanted to refactor the code because in this project I did a whole lot of experiments trying to figure out what will work and what wouldn't work. And I think in today's video, just to remind me of what I was doing and just to recap for everybody how far we've gotten in this project, I'm just going to focus on refactoring the code today. I'm probably going to live stream to like 12 p.m., 1 p.m. ish. And after refactoring the code, then during next week's live stream, what I'll do is I will actually build the project itself. I'll actually build the model. We'll start with this is a regression problem, so we'll just start with a simple linear regression model, and then if a linear regression model can't give us a good enough accuracy, we'll probably experiment with a tree based regression model and then move on from there. And just to quickly recap, last time we worked on this project, I created a visualization just to get an idea of what we have here. And I believe this is like the visualization, and I took a sample, I took a sample of 100 items from the entire data set to create a visualization. And the visualization itself doesn't tell us much. It looks like a whole lot of scatter plot. I mean, it is a scatter plot, but it looks like the visualization right off the bat doesn't give us much visual cue about what's going on with this data set. And if you remember, we had two targets, two things we are trying to predict. So let's go back here. So we said something like the target was monthly insurance premium, as well as something as we have one more item as our target. So our customer lifetime value and monthly insurance premium. So we have two separate Y targets, and we're going to basically do two separate experiment-ish, trying to see if we can predict the monthly premium auto and the customer lifetime value. We'll see. So today's is not going to be anything fancy or anything super. Like most times in coding, like there's nothing fancy going on, nothing super going on. It's just good old boring coding job going on. And so today I'm just going to refactor the code, and then next week ish. Ooh, look at this graph right here. So if you're looking at this graph, monthly premium auto and total claim amount, there seems to be like kind of like a positive correlation between your auto premium and the amount of money you have in claims. This graph right here, that's been an interesting one to explore. And then this one, which is a monthly premium auto and total claim amount again. So basically the only graph that looks sort of interesting-ish is monthly premium auto with total claim amount. The other graphs is mostly scattered information, doesn't give us much information just by looking at it. So yeah, what we can tell from customer lifetime value right off the bat is that majority of the customer lifetime value is less than 20,000, right? It's less than 20,000 here, and majority of the premium autos is less than $150. And there seems to be an even distribution with months since last claim. So yeah, I wanted to create some visualizations just to get an intuitive idea of any relationships that might exist between the futures, but we really can't see anything here. So I'm basically thinking maybe a linear regression model is not going to have the best performance, but I don't know yet. And I have to use a linear regression model as my what's it called, mean baseline. Actually no, duh. No, like I have my mean baseline, and basically our goal is to see if the linear regression model can beat the mean baseline. And also yeah, actually I just changed my mind. You know what, we are going to build the models today. I'm feeling excited, I'm feeling very positive. I'm going to build the models today. And then next week we'll do the code refactoring. And I know I said this last time. Okay, so last time I worked on this project, I was like, I'm going to refactor the code today. And then as I was right about to do it, I changed my mind. I was like, nah, I'll do it next time. And the same thing is happening again to me today. I'm just like, I'm gonna refactor the code. And then I changed my mind. I'm like, nah, I'm just gonna keep working on the project. I'm going to refactor the code eventually because I mean the code works from beginning to end, but there's so many code cells that could be combined into a function, and all that stuff. So I'm working from a virtual environment that I created for this project, by the way. So I'll just go ahead and run this. I do not want to run everything here. Let's see. URL open error gets additional info failed. What is it talking about? That's the first time I've seen this. Let's see here. Let's copy this URL and make sure it still works. I think my Wi-Fi is acting up. hence it could just be a Wi-Fi problem. Yeah, my Wi-Fi keeps disconnecting and reconnecting. Okay, things are work. Let's try this again. And okay, it was a Wi-Fi problem. So I'm just going to go ahead and run everything. Well, I don't want to run everything because some code cells take a long time to run, but I'm just going to run enough to continue with the project. Really, I'm going to do code refactoring next week. I promise. Next week I'm going to refactor the code. All right. All right. So I'm not going to run this code cell because it takes some time to run, and right now I don't need this information. Okay. Let's see. These are just notes that I made for myself. I just need to run all the code cells necessary for things to get going, really. So my like super, give me a second here to adjust. My super game plan is to eventually like put this project online, so like kind of use Flask to put this project online. That'd be really exciting. I'm not very good with Flask yet, but that's okay. I'm going to learn. I found some tutorials on YouTube that's really going to be helpful in showing me how to use Flask. And then I also have another project that I created that I want to put online using Plotly. So I want to learn how to use Plotly and how to use Flask really well. What is it talking about? All right, let's run out these code cells. We need to run out these code cells in order to get to the make sure our data is ready for analysis. And this is also why I need to refactor my code. When I refactor my code, all of this is going to be in a function. Well, majority of it is going to be in a function, and um, that will make it easier, so I don't have to run so many different code cells before I get to what I want to do. Next time when I start up the project, I don't have to run all these code cells before I get to what I want to do. And yes, I could have gone up here, runtime, run all cells, but there are some code cells that I don't want to run because they take a lifetime to execute. Alright. Alright, so let's see here. Now we are getting to the part where I really don't want the codes to run. Let's see. I do want this to run, and I want this to run. So this is where we start working on our visualization. I don't mind. Oh, I think I found out last time that Plotly scatter plot doesn't work very well with doesn't work. Plotly scatter plot doesn't work well in Jupyter Lab, but it does work in VS Code. Maybe I'll open this project in VS Code. That doesn't actually. I think I might do that. Let me go ahead and save everything. I haven't made any changes. Let's see. Copy path. CD. Oh, CD. Um, Before, okay. I'm opening up VS Code now, so let's hope it works. Sometimes VS Code doesn't work and it pisses me off. VS Code knows exactly what to do, but it doesn't behave always, and it makes me mad. Okay, there's a see. This is my problem with VS Code. Sometimes the IPython kernel doesn't start. So there's an IPython kernel that's supposed to start when you open a. Let me go into the pip environment first. That might be the problem. Pip shell. So I am in the pip environment now, and now let me do code dot. Let's see if that fixes the problem. See, this is my problem with VS Code. Sometimes the IPython kernel. Yeah, it didn't work last time either. Sometimes it works, sometimes it doesn't work. Yeah, I ran into this problem last time too, so yeah, the IPython kernel is not starting for some reason. If you go to, let's say, extensions, um, yeah, it's not working. I don't want to waste time on it. Let me exit the virtual environment because I don't need it. Alright, let's get back to work since that didn't work. But I found out that the plotly doesn't work well in Jupyter Lab for some crazy reason, which is fine. Um, so all these plotly graphs are not going to work, and I don't need Seaborn. If I was in VS Code, you'll be able to see the graphs, but right now I don't need it anyway, so it's fine. So there is one graph though I wanted to look at. Look at total claim amount and monthly premium auto. And one thing I don't like about Jupyter Lab is that there's no autocomplete. Trend sample is what I need. Now this graph is not going to show up And at the end of this video, I'll try to open it again VS Code and see if VS Code will behave. Oh, I might even try to open it in. I might try to open it in I'll see if I can just open it using regular Anaconda. See if that makes a difference. I don't know. And then x equal to monthly premium auto, y equal to total claim. This graph is not going to show up right now, but when I go back to VS Code or a different IDE, then this will show up. But I just wanted to put this here so I can remember that I wanted to look at this. Now, so let's start with let's say so we have training, and let me just refresh myself. So we have training sample from train encoded. Alright, so we have our train encoded, and we probably have our test encoded too. Train encoded, test encoded. Okay, I don't think I've not, let's say, so train encoded has customer lifetime value as well as monthly premium auto, which means I have not done the test splits. Train test split. I haven't done train test split. Alright, so train test split x and y. Right? Yeah, so from sklearn.model selection, import train test split, and then I want to do x train, y train, x tests, y tests is equal to, hold on, because I said two separate y variables. How do I want to do this? I kind of want to see y1 is going to be monthly premium auto. I want to predict monthly premium auto. I also want to see if I can predict customer lifetime value. So these are two separate problems, right? And since this is a regression problem, I'll just frame it as two separate problems, and I'll run it as two separate models, two separate everything. And I think customer lifetime value is going to leak information to monthly premium auto, so it's good that I'm taking them out of the entire data set. Let me see. I could also I think total claim amount can leak information into the monthly premium auto, because if you think about it, when you first get insurance premium, like the new insurance company doesn't know how much money you are going to claim, but once they have information on how much money you are going to claim, then then your insurance premium is going to go up. So I'm going to remove total claim amount from the data set because it could leak information into the customer lifetime value and monthly premium auto. So let's see. Remove leakage future, which is equal to total claim amount. And here I'm going to put y. When I turn this into a blog post or when I put this online on a website as its own project, and I want to remember why I remove total claim amount from as a potential data leakage. So basically, I wrote down here that the reason why we are taking total claim amount out as a future that will leak information is because total claim amount is from the future. So basically, like when you first get an insurance premium, you don't know how much you're going to end up claiming in insurance, and the insurance company itself doesn't know that information, right? So it's not taking that information to predict your insurance premium. It's not going to be very accurate because that means you're pulling information from the future. So whenever you think you're taking information from the future, it's most likely data leakage. So I'm taking that one out because I think it's leaking data into everything. Alright, so um I think, okay, so how do I want to do this, right? Because I want to have two y columns. So I'm going to do this project one problem at a time. first I'll start with monthly premium auto, and then I'll do this all over again, starting with customer lifetime value. Like, I'll build models for monthly premium auto, then I'll build models for customer lifetime value. I think that's how I'm going to do it. So let me go ahead and add a note here and make this into a markdown. Build two separate models. A model for monthly premium auto and a model for customer lifetime value. I think that's how I'm going to tackle this problem, because from a customer's perspective, they may want to know what their monthly premium auto could be, and then the insurance company may want to know like the customer lifetime value. If the insurance company knows the customer lifetime value, they might maybe invest more money in advertising, in like running ads and trying to find customers that will give them the maximum customer lifetime value. So it's interesting. If you hear background noise, just know that's one of my roommates. Okay. Just know that's one of my roommates. Alright. So the first model I'm going to build is, so I'm going to make this clear to myself, and the reason, and it seems as if I'm over commenting, but this is necessary. So this is monthly premium auto models, and then once I finish building monthly premium auto model, once I find like a model that is good at predicting the monthly premium auto, then I'm going to go back and build another model for customer lifetime value. Okay, so I'm going to do train test split, and then in the parentheses I'm going to say this is x train encoded, um, I want to make this capital, no, not capital, like I want to make it bold. Alright, so let me just get it. So x train encoded, you just got train encoded. Okay, then to make sure I have the right name, so train encoded, and I've already done a no, I've already done a train test split. What am I talking about? I've already done a train test split earlier. Hold up. See, this is why I need to refresh my memory on my own project once I come back to it. Train encoded and test encoded. I've already done a train test split. Let me see. Give me a second here to. Yeah, I've already done a train test split earlier. I don't need to do that again. Mm, mm, mm. Yeah. Okay. Scratch that. I just need to X train. Okay, well, let me start with my Y train really. So my Y train for this project, for this part of this project, is going to be X train encoded, and we said monthly premium auto. Some Akil has a question related to F string Python. Yeah, go ahead. What's your question? You can ask your question in the comment section. F string literal? Is that what you're talking about? Yeah, go ahead and ask your question about it. Y train, and I'll try to answer it. So Y train is equal to X train encoded monthly premium auto, and Y test is equal to X train encoded. Actually, I can put this in a new defining Y variables. X is equal to X train, basically the same thing. Okay, so my Y train is my X train encoded. Okay, it's just string. I keep forgetting the name of the data frame. Let's go ahead and execute this, and now let's type in Y train. Okay, that's our Y train, and then Y test. No, my Y test is test encoded. Let's run this again. Run this, and I want to get print length Y train. So about 6,598, which makes sense. Let's change this to test. Just getting a preview of the data, make sure. Okay. That doesn't make any sense. Didn't I just change this? Let's see. Test encoded dot shape. Train encoded dot shape. So my train data and my test data is the exact same length. That's strange. What did I do up here? Insurance. Let's just start with insurance dot shape. Let's do that doesn't make any sense. Insurance dot shape. Okay, yeah, something is off here. I mean, it makes sense that it has more columns here, but let's see. My insurance is 9,000 rows. My test encoded is this many rows and this many rows. Okay, something is up. What did I mess up? I messed up something up somewhere, because my test and my test encoded should be about, it should be 9,000 minus this, so something is off. Test encoded size should be this number minus this number. Yeah, so my test encoded should be about 2,536 words. I need to scroll back up a little bit and kind of see where I messed up, because something is not right. Something is not right. Okay. Yeah, okay, that's not right. I messed up somewhere. I messed up here. Okay, so okay, so let's see, test encoder equal to test encoder dot drop. Okay. There's been an error in my code somewhere, and I'm trying to see where the error occurred. Let me see. This is going to throw an error. That's normal. Yeah, there's something off. So I'm going to save everything here. Just give me a second to. So there's been an error because they should not be the same size. Like something is not right. Um. I'll go ahead and let me see, comment out the code I don't want to run. So I don't want to run this code. And then I also don't want to run this code because it takes forever to run. So I'm gonna comment it out. And I also don't want to run this code because it takes forever to run again. So now that I've commented out the codes that I don't want to run, let me go ahead and restart my kernel and run everything. I'm trying to see. Okay. Everything is done running now. Let me see. Okay, so that's encoded as shape is still giving me okay. Looks like I need to go all the way back up, like way back up. Let's see here. So that's the thing about coding. Can never everything. Why can't everything just be perfect? So where did I do my train test split? Alright, so this is my train and test, and I'm splitting insurance into train size and test size and random state. Okay, train and then validation. So I do have a validation data set. Okay, I want to split the train into the train size. Alright, let me go ahead and run this code cell again. And in this case, let me do train dot shape. Okay, that makes sense. And let me do test dot shape. Alright, so in this case right here, and everything is right, and let me do val dot shape. Okay, So right from here, something is right? So the error came from here. Ah, see, found it. I feel like a genius right now. This is the problem. So here, I did train encoded equals education encoded dot field transform train encoded, and then I said that test encoded is also train encoded, but this is test encoded. Haha, gotcha. I gotcha. I knew it. I knew something like this would have been the corporates. I knew it. Oh. Alright, so where I define my testing. So this is yeah. And this is why it's important to refactor your code. When you refactor your code, it's easier to kind of see where there's mistakes, because you have to go through your code all the way again from beginning to end. Yeah, yes. That's what the problem is. Now let's go ahead and I want to run everything all over again. And now let's see if the problem is fixed. Fingers crossed. Oh, I'm so excited. I knew something like that was a corporate. I was like, why do they have this exact same size? Like, that doesn't make any sense. Let's see if it's fixed. Alright, yeah, that's more like it. See now, my test encoded has the right number of rows. That's what's up. That I felt so. I was like when I did this, when I did y train shape and y test shape, and they came out to be the same. That's how I knew there was a problem. I was like, no, my y train should not have the same shape, should not have the same length as my y test. And that's how I went this rabbit hole of investigating, like, hey, what the heck is wrong here? Like, what's going on? Alright. Alright, so we define our y train and our y test. And now let's go ahead and let's go ahead and drop our other column. So in this case we are going to drop define x variables and drop leakage column and y variables. Okay, so columns to drop from X data set. Monthly insurance premium, and of course we want to drop our y variable, so you don't want your X data set to contain your y variables or data leakage column. So we want to drop monthly insurance auto, monthly premium auto, like that. We want to drop that. We want to drop customer lifetime value. We want to drop customer lifetime value, and then we also want to drop total claim amount, because we think it could be leaking data. So I'm gonna put this in a did I just do that? I did. So these are the columns I want to drop, and then to actually drop it, I'm going to be like X trend is equal to trend encoded dot drop columns equal to drop columns, and then I'm going to do X trend dot head to see what I have here. Okay, so let's say did it drop it? Let's see. It did. Customer lifetime value, we don't have any of that anymore. And of course we can also do xtrend dot shape, and you see that it now has 49 columns. And then we can do the same thing for our X. Actually, I want to do print. I want to put this X test dot shape. So as test. I'm about to make that mistake again. Test. Alright. Let's go ahead and run this. We have our S test is 49 columns too, and it has the same right shape. So this is good. Alright, so let's see here. So we've split our stuff into X train, Y train, X test, and Y test. Now let's start by establishing a mean baseline. So baseline model, and I know I said baseline model, but it's not really a model, it's more like a baseline. So if you don't know this already, for regression problems, the mean serves as a good baseline, and for classification problems, the mode serves as a good baseline. If you didn't know that, now you know. So I'm just going to establish my mean baseline. And to do that, I'm going to establish my mean baseline. So, and then my baseline accuracy. So basically, for regression problems, the metrics that you use to measure a regression problem is not the same metrics that you use to measure a classification problem. With a, what am I even talking? Let me just show you. What am I searching for? I'm searching for I'm searching for Scalar pre-processing. No, metrics. Yeah. So basically, for a classification problem, these are kind of like the metrics that you use to measure a classification problem. These are classification metrics. And then for a regression problem, which is what we are doing right now, these are the metrics that you use to kind of measure what you're using to measure your model, basically. So in this case, sometimes you have to explain why you're using the metric you're using. So, but in this case, I'm just going to use the mean absolute error and the mean squared error as my metric of measurement. Why? I don't know. That's what I've always used. I really don't have like a good explanation as to why I use this, but they are like good starting measurements point, good starting metrics to use. So let me see. So this is my mean baseline. It's equal to mean is equal to y train. Can I just do that mean? Wait. Is that even a thing, dot mean? I've never even tried that. Hold up. No, this is so wrong. Wait, what? It works? Really? You can. But have you ever used that code dot mean before? How did I even get that? What? Hold on. Have I ever used dot mean before? Did I just invent that on the spot? Yeah. 93.4 something 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 is the mean indeed. That is crazy. How did I even know to do that mean? I don't know. Sometimes you do something so often it just becomes automatic and you question your own self and you're like, wait, does that even work? How does it work? But anyway, I guess it worked. So this is our mean baseline. So what does this mean in English? This means we predict. So this means without using a model. Somebody's calling my phone. Give me a second to see. Somebody was just calling me. I declined it, so it's fine. I'm back. So that's using a model. We predict that insurance premium would be um $93, and that is not the dollar symbol. I could round this out and run this again. There we go. So um $93.49. So that's kind of what the mean baseline means. So this is just our mean, right? So now we need to figure out how wrong we are, and we figure out how wrong we are by um calculating the mean absolute error or mean squared error. So let's go ahead and open this matrix. So sklearn.mean squared error. Let's just do mean squared error first. So y true and y predicted. Okay, so grow through correct target values and estimated target values. Hmm. Mm. How do I'm trying to think. How do I format this so I can do a mean squared error? Because give me a second here to look up something real quick. Give me a second here to look up something real quick. Just give me a second here. I feel like mm, 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 mm. Okay, so yeah, I was like I'm missing something. Okay, so we have our mean, right? Now we need to figure out our error. So basically the error is equal to our mean minus our y trend. Okay, and let's type in error here. Okay, yeah, so this is basically our error. Something didn't add up before because I was like that doesn't make any sense. And let me go ahead and just make a git comment real quick. So let me go and get status, get add, git commit beginning of model building or something like that. Git push origin master. Alright, so and I'm just gonna double check to make sure it's online, because I've had problems sometimes where like I push to the wrong, I push okay, this is the wrong time. Insurance premium 33 seconds ago. Beginning of model build. Okay. What has it been like 2 months since I worked on this project? Damn. Alright, so basically this is my error. So basically to get so this is the mean baseline, right? And then we need to get our error of our mean baseline, and then to get our mean absolute error of our mean baseline, if that makes sense. We just do so mean absolute error is equal to the error that we have dot absolute dot mean. All right. So our mean absolute error is 25. So we are off by $25. So let's put this in like I don't know, English terminology. So let's do print f string literal if so by guessing, comma, our insurance premium would be comma 2, and then in a new line I want to say something like and we would be off by round mean absolute error and 2. All right. So by guessing, our insurance premium would be $93. Would be, let's add some dollar symbols to this to make it look even more cooler. Alright, so by guessing, our insurance premium would be $93 and we'll be off by $25. Sounds good to me. So that's the mean absolute error. So that's kind of our mean baseline. So our mean baseline is our mean prediction with $93 and our mean absolute error is $25. So our job here is to kind of reduce this, if that makes sense. You know, and if you're doing a classification problem, the higher the accuracy, the better. But in this case, we want our error to be less. So the job of the model we are going to build now is to build a model. Our job now is to build a model that has less error than this, if that makes sense. Alright, so give me a second here to look at something. So let's start with, actually, don't just do mean absolute error, don't also want to do mean squared error. But how do you calculate mean squared error manually? So that's mean absolute error, and this is mean squared error. I wonder, how do you calculate mean absolute errors? What's the code for it? No, mean squared error. Isn't mean squared error just a square root of mean absolute error? Most times you use like libraries like this, and it kind of like takes away from like the underlying math behind it. Let's see here. Let's go to Wikipedia. Why not? So is it gonna show us the math? That's way too much math. Hold on. Average of the squares of the errors. Average square difference between the estimated and I'll just appreciate it if they just let's see. I know you could use mean squared error here, but my question is like, hold on. What's the math between mean squared error? Yeah, I know you could use mean squared error from Scalar, but it's like, what's the math actually behind it? But I'll figure that out later. Um, what if like the mean squared error, I could be wrong, is equal to the square root of this? Square root of the absolute mean error. I think that is the mean squared error. Again, I could be wrong. I will have to double check on this later. square root. How do you do square root in Python? See, whenever you're coding, you're always finding you actually really stay focused on what I'm actually doing, on the project I'm actually working on. But why stay focused when I can just diverge? So square root Python sqrt. Okay. Square root is not defined. Knew it. Math dot square root. Import math. That's what I'm missing. Okay, so so is square root of mean absolute error mean squared error? Am I crazy? Square root of mean absolute error. I'm definitely not crazy. Mean squared error. The average of the square root of the difference. No, I mean, like, how do you do it without using Scalar? So these people are just driving me nuts. So this is something I'm going to find out later. How do you calculate mean squared error without using a oh, hold on. No, this is not accurate. Actually, this is, see what I did, it's a root mean squared error. So absolute, so I need to this minus this squared instead of absolute, and then parentheses, and then square root of that. So this is the formula for it. I'll look into it later, but anyway, this is wrong. Yeah, this is wrong. It's called mean squared error. So square root of the error. Like I said, I figured this out later. I'm just crazy. Let me put a note for myself to figure this out later. How to manually calculate mean squared error. I think this might be right, but I don't know. I figured this out later. Anyway, moving on. That was a little divergence from the real thing. Let's go to Scalar linear regression. So I'm going to start with a linear regression model, and basically this is what we are dealing with here. So fit intercept true, what is the score that is using? Hold on. Coefficient, rank, singular, intercept. Okay. dot score, let's say. So the score method returns the coefficients. That's not necessarily the metric I'm using. I'm not using the coefficients, so I won't be using that. um okay, let's do so. From sk learn dot linear model, import linear regression and lr. So this is me instantiating the linear regression model. Oh, by the way, if you click alternate enter, it runs the code cell and then creates a new code cell below it. And so let's see. I'll just call it linear regression model is equal to lr.fit x train y train, and that's basically it. And then I'm not going to use the score model. Alternate enter. Invalid type promotion, let's see. Huh. I don't know what the problem is. Okay, so array like sparse matrix of shape and samples and futures. Alright, so what exactly is the problem here? Sample weight is none. What do you mean? Y numeric is equal to true. Invalid type promotion. Huh. I haven't dealt with this problem before, so let's I think my y needs to be in the form of a data frame. So let's try that. Invalid type promotion. Let me see. Let's try this. No. I'm not quite sure what that means. Invalid type promotion. Let me see. Let me just check my extra real quick. Activation date. Why do I have activation date here? activation date doesn't matter. So if I drop activation date, might that help? So let me see. Trying to figure out why this invalid type promotion. So so we don't have activation date anymore. That is the only suspicious column that I had there, because activation date is not necessarily wasn't necessarily an integer. It's probably considered a date time, but the activation date anyways doesn't matter in the model. So but let's run this again and see. Oh, look at that, now it works. So the problem was the activation date column. That's where the problem was. So it didn't know how to handle that column, which is fine. We got rid of it. So this means we also need to let me make sure. Linear regression model didn't like it. Alright, so let's also drop this from the X test so we can do prediction. Alright, so the S test, so fit in the model, so predicting Y values using test dataset. So LR so Y predict is equal to LR model dot predict S test okay, and alternate enter. And now let's do let's just type in white bread, why not, just to get a preview of what it looks like. So this is our Y prediction. Of course this dot 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 means there's a whole lot of things here, but nothing fancy there. But now let's why don't you do this? Actually let's just compare our model prediction to the actual values. Okay, so let's just print Y bread at 0 position. Control Z, print, and also let's print our Y true. Of course I'm going to calculate the at the 0th So this is like predicted value for first row, and this is the actual value for first row, and this is just using our linear regression model. Oh, hi, is it beams? No, I'm sorry, Baemes. How do you say your name? Sorry. Beam beam Beamis. I don't know, I'm butchering your name right now and I feel so bad. Sorry about that. But hi, welcome to the live stream. It's just me and a couple of people here. Let's go ahead and execute this. Let's see. Yeah. This is because my white test is not designed as a list. I don't know. This is just me trying out something. Let's see. This is just me putting my white test in a list so I can index it. I couldn't index it before because my white test wasn't in a list format. So let's run this again. Ooh, look at that. That's not too bad. So basically the actual value for the first row is 106, but the predicted value is 109. That's pretty good. Now let's look at our metrics, right? So from sklearn.metrics, I believe that's what it's called. Import mean squared error and mean absolute error. Okay, and now let's see what our mean squared error. So mean absolute error is equal to mean absolute error parentheses. Our y true is y test, and our y predicted is this, and then mean squared error is equal to mean squared error parentheses y test, which is our true value, and y pred, which is our predicted value. And then I also want to do okay, let's just start with those two, and let's say print with f string literal and to print mean absolute error, linear regression to be specific. Mean squared error. So our linear regression mean absolute error is 5. Damn, that is wow. and our linear regression mean squared error is 50.9. That is really good. So remember, like, um, the the linear regression model actually did well though, because if you look at our baseline, right? If we go back to, if we compare that to our baseline, no, this is wrong. Remember, this is wrong. Our baseline mean absolute error was 25, and our mean absolute error with the linear regression model is 5. So that is like, that's pretty good. Wow. I didn't think the linear regression model would do so well. Like, it would be interesting to compare this to like other, yeah, this is, hold on. I wasn't expecting like the um linear model to just be that good. Um, let me see here. Now what we can do is we can get kind of like the coefficients and kind of see like, you know, we can see like which, I'm just sitting here, if I'm not talking, I'm just sitting here thinking and looking at this. So the next step we could take here is like, we could look at what coefficient contributed to the score. In our linear regression model. I'm just sitting here thinking, don't um and this linear regression model is kind of using all the features, right? So one thing we can do is we can do what did I call my model? I called my model LR. So we can do LR model dot coefficients. I believe that's how it's spelled. I think it's just one F. So these are the coefficients that kind of played a role in our prediction, right? So these are the coefficients, and now I want to know the intercept. Is it called inter something? Intercept. So our intercept was 100. Okay. So basically, I'm going to work until 1 p.m. here. But what I want to get done today is I want to look at the features that had the most impact in our predictions. Okay, so yeah, and then on next week's live stream, I'm going to do the second. I'm going to try other models. But also I'm going to um, get started on the second thing we wanted to predict. So we want to predict monthly premium auto and customer lifetime value, right? So next week I'm going to try other models on the monthly premium auto, but this linear regression model did well. But I could also try like other regression models, and then I will build a model for customer lifetime value. Yeah. So let's see here. So I could I want to check something. So our bread mean is $91. Hmm. Give me a second here. I'm just thinking. Um. I'm just thinking, because when I started this project, I really didn't have like a solid plan of what I wanted to accomplish, or like where I was going. But um give me a second here. Hmm. Yeah, so I should have probably planned this a little bit more, because I was like, okay, I want to do this prediction, but it's like, okay, let's go back here to my notebook, and I want to find something. So let's see. I think it's this project. Give me a second here. So let me see. Now I'm beginning to think about like, what do I really want to do here. So basically, the way I want this is that okay, so I want to first see what factors play a role in what features are most important in the linear regression model, and then build out something where you can input different numbers and get a prediction. That's what I'm trying to accomplish. That makes a whole lot more sense now. So kind of like so when I build the Flask app, I want the users to input their data and get a prediction. Okay, that's that makes a whole lot of sense now, because I was like, where am I going with this? What do I want to accomplish? Okay, so let me go ahead and save all. Let me go ahead and commit this. Why not? So get add, get commit. Cool. Okay, so basically, let me see. How do I want to do this? Let me see. I think it was in this project where I did something similar. Um, mm, 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 mm. just give it. Okay, there we go. So I think whatever. So yeah, I think this was also a regression problem that I did, and yeah, as you can see in this project, I tried many different models, but let's see. This is what I'm looking for right here. So this is the R2 score. I could use the R2 score here, but I don't want to. So I think I used a pipeline here. Yeah, I used the pipeline model here. I didn't use the pipeline in this one because if I use the pipeline like this one, then I'll do my encoding and my standard scalar first. But I didn't use the pipeline because I don't use this exact same encoding for everything. Like as I went through the project, some things I use ordinal encoding and some things I use one hot encoding, and I tend to keep like the encoding process apart from the model building process just to make it easier for me to see and understand later. I think this is a ridge regression model here, and I think this is the this is the linear regression model. So what I'm looking for here actually is, let's see, the mean absolute error, linear regression dot name steps. So that's the coefficient. Okay, so that's the intercept. Okay, but that's not really what I'm looking to build here. There's something else. Okay, so plotting the coefficient from linear regression model. So this is what I'm trying to do here. So the encoder, names one hot encoder. Okay, so I have to put them in a dot columns. And I use coefficient error as a global one, and then I believe all the way at the end what I did was I did okay, this is the code I'm looking for here. Sometimes I have to go back to my own projects, my old projects, kind of like remember how to do something, and that is why I comment my code a lot. Like seriously, as you can see, just a whole lot of commenting here in this project. But the reason why I comment my code a lot is when I need to go back to it so I can remember how to do something, I won't be questioning myself like, what was I trying to do? I'm not going to need all of this code, but I'm just gonna take it and I'm going to modify it as needed. Okay, so to create so coefficient error dot sort values dot plot colors equal to gray, and I copied the wrong code. Give me a second here. This is what I need here. Okay, so this is what I was trying to do. Okay, so I want to see which features um, has a significant impact in predicting the life insurance premium. Alright, so let me write that down. So which features has significant impact in predicting auto insurance premium, not life insurance premium. Okay, and also I want to try other models to kind of look, kind of compare the mean absolute error between um, the linear model, the linear regression, the linear regression model, and the other models that I have. All right, so the linear regression model here is giving me a mean absolute error of like 5, which is good compared to our mean baseline absolute error. So this is my coefficients. I'm gonna need this, and I'm going to need the column names. So, and this is my intercept. So let's see. So the columns that I'm going to be using is equal to, let me see, can I just get, let's see, could I get it from here? No, I don't think so. I think I can just use my X train columns. Yeah, I could just use my X train one. So my columns is this, and I want to create a series between my columns and my coefficients. So alright, so this is necessary for me to be able to plot to see. Do I have matplotlib? I think I have matplotlib here, but I'm just going to import matplotlib. Okay, so I'll just put linear regression graph, why not? And to sort the values, and sort values, I believe descending or ascending is, and then descending is the default. I need to plot it and to do a bar graph, and I want to give it the color red, why not? And visualization for linear regression model coefficients. Alright, did I call this code F? Yeah. Let's go ahead and run this, and let's just do LR graph, just so you can get a view of what it looks like. So basically this is our graph. This is a pandas series that's combining my coefficients that I showed you earlier and the columns they are associated with. And then and now I'm just gonna plot it. This might throw an error if I don't have matplotlib already. Yeah. Name PLT is not defined. Oh. import matplotlib dot py plot. I believe that's what I need as plt. That's not very helpful. So how do I make this okay, I don't like this graph. It doesn't look quite right. Let me see. I think I need to make a few changes to make the graph look the way I want it to look. Let's see. What I need to do something to let me see. So matplotlib pyplot as plt, yes. Map, this might help. Let's see. This is just to make things bigger. No, doesn't quite solve my problem of I'm trying to see how do I make the graph look a lot better. Let's see. There's something I did here. Give me a second. I know what this problem is, and I'll fix it in a second. Could it be that this is just a oh, I can just change the width and height. Okay, so let me see. Yeah, I can just change the height and width to make it bigger. Horizontal bar graph. From matplotlib.pyplot, import figure, and then you define the figure size. Okay. Figure dot set size inches. Huh. Okay, so we can use this code to change the size. Let's try that. And I don't think I need this code here because why would I need that? And it doesn't make sense that I put this up here anyways, because guess what? come on. Let's see. You've got to be kidding me. This is wow. That's not very nice, you know. My screen is dark and this Python thing is dark. Okay. I guess I'm going to have to type it out manually. I'm here. Okay, let's see. From matplot. Okay, and they have this plt. Okay, oh well, no. From matplotlib.pyplot import figure. Okay, and then figure fixed size equal to well, let's just do 10 by 10 and see if that makes any change to start with. Oops. Oh, see, that works. Okay, thank you, Stack Overflow. What will I do without you? Now visualization looks a whole lot better. So, yeah. So, so what we can see from this coefficient graph is that having a luxury car, having a luxury XUV, and coverage, and the type of coverage you have increased your insurance premium by a whole lot. And then the things that had a negative impact in your insurance premium is sports car. Oh no, what things that had a positive impact. So it's positive impact related to a lower insurance premium now. So these are the things that positively impacted the prediction, and these are the things that negatively impacted the prediction. So having a 4-door, a 2-door, an SUV, or a sports car. So basically, the type of car that you had kind of like really has an impact on your insurance premium. And then income actually didn't have, like, almost had no impact in your insurance premium. That's good to know. I wouldn't have predicted that exactly, but that's what the data says. Your gender didn't have much impact. The state, let's see, where's the other states? Being in Arizona had being in Arizona, states like Arizona, Nevada will have like lower insurance premium than, let's say, being in Washington. So basically, this right here is showing us the coefficients that had an impact in the prediction, right? So for our linear regression model, so this is called model interpretation, this right here. So basically, for our linear regression model, it's telling us that if you have a luxury car, a luxury SUV, and the type of coverage you have will have an impact, will like make your insurance premium go higher. But 2-door SUV, 4-door will lead to a lower insurance premium. So that's what we are looking at right here. That's what our linear regression model is telling us. And these are the coefficients here. So basically this graph right here is all of this right here. So yeah, based on this linear regression model, what we are seeing is that the type of car you have is what has like the greatest impact on your insurance premium. Who knew? And the rest of this is almost blank. Now, is this like the most accurate thing ever? No, it's not the most accurate thing ever, but this is kind of like a starting point in our modeling to kind of start getting an idea of what's going on or what could impact your insurance premium. Let's see. Um, and in this project, I think I used permutation importance and PDP and so that's basically what we have so far for the linear regression model. I think I want to try, let's say, other models. And why do I have PLT right there? That doesn't make any sense. Alright, so I'm gonna try this again. I'm going to repeat this process, but this time I'm going to do it with a different model, if that makes sense. Give me a second here. Normally I'll put all of this in a function, but like I said, I'm going to refactor my code when I finish. I'm going to refactor my code and put all of this in a function and make it look prettier and better and stuff like that. But let's see. I want to now I'm going to put all of this in a single code cell. And it's going to be a lot of scrolling back and forth, but you'll see. I don't want to just stop at a linear regression model, but I want to try other models. Let's just put it that way. And after trying out other models, what I might find is that the linear regression model has like the best performance, so but I wouldn't know that until I try other models. Coverage really does have an impact. Alright, so let's see what I want to copy from up here. I want this information. This time I'm going to do everything in a single code cell, and when I refactor my code, it's going to end up looking something like this, where I have a single function for like all the models that I tried, and then I just call on that function one time, stuff like that. That's what the code will look like once I finish with this project. when I start the refactoring process. Let's see. And then I guess I could put the visualization in the graph over. Okay, so this is um, and also hold on, let me see if I can find this um, models for regression problem. So a random forest is kind of like a tree-based model, and linear regression is a linear-based model. So let me say if Scalar has linear models. So these are the linear models that you find in Scalar, and the one we just did is, so this, yeah, this is exactly what I'm looking for here. So basically polynomial regression, I could try logistic regression. So basically you could go try all of, you can try different models, but this is not necessarily what I was looking for. At scalar.linear. Okay, this is what I was looking for here. So basically here, if you're like worried, like if you're like, hey, what type of models should I try for my problem, well, I always start with like the ultra basic model. So in this case I just started with a linear regression model. Okay, and then if you go to this website, if you just Google linear regression model, linear regression Scalar, and then click on this part, it will take you to this page. And basically it tells you like linear classifier. So these are the models you can use for classification. Classical linear regressors, so linear regression is one of them, ridge regression is one of them, ridge CV. Ridge CV is where you put in different alphas. So with a ridge regression you put in an alpha, and in this case, so basically I've used ridge regression model. And I think I did a ridge CV before where I tried different alphas. So if you go back to this project that I did here, let's see, give me a second. You know, I have an assignment to do today. I need to get to it. That's why I was going to end at 1 o'clock, but so in this ridge regression problem, I just used an alpha 10. So I think I used alpha 10 because I did a ridge regression problem before I refactored my code into like one function like this. I did a ridge regression problem where I tested different alphas, and then I found out that alpha 10 gave me the best prediction, gave me the lowest error score, and that's why I ended up using alpha 10. But before I decide on which alpha to use, like which number to use, so basically alpha is how many features to use, right? If we go back to here, I think they might be talking, I think they talked about it, I'm not quite sure. So but anyway, so I think alpha represents like the number of features to use or something like that. But anyway, back to what I was saying. So if you're worried, if you're like thinking which models should I use or which models should I try, but depending on the problem you have, that will determine the type of model that you use. So if you're working with a regression problem, if you're doing a classification problem, you can use classifiers. If you're doing a regression problem like I'm doing right now, you can use regression models, and in this case I just use the linear regression model. And of course I could try these other models, but I don't, at least not right now. If my linear regression score was like worse than my baseline error, then I might try these other linear models. And then there's regressors with this Bayesian regressors, multitask linear regressions. I don't even know what some of these models does. Like, it's a whole lot of like models you could work with. So classification metrics, we're not talking about metrics. Let me see. Feature extraction, I've done that before. Let me see if I could find what I'm looking for here. Scalar, random forest. No, I'm looking for random forest regressor, not classifier. So use random forest classifier when you're doing a classification problem, or random forest regressor when you're doing a regression problem. And I know that might seem like intuitive. Actually, I want that in a different. So these are the ensemble method that you could try. Tree-based models, right? So you have the classifiers and then the regressors. So in this case, I'm just going to try random forest regressor. And this is another model that you could try. You know. So I've done one linear based model. Now I'm going to do one forest based model. So I believe is scalar.ensemble.random forest regressor. From scalar.ensemble, import random forest regressor. And I'm just going to do a random forest model real quick, just to get an idea of what the error is going to look like. And then I might do a visualization similar to this one to interpret the model, and then we'll call it a day. And then next week when we come back, we might do some more model interpretation, and then create models for predicting our customer lifetime value, right? So this one is just focused on insurance premium. Next one we are going to do is going to focus on random forest model. On customer lifetime value. I'm just going to call this RF is equal to random forest regressor. I'm just going to use the default parameters. So when you're doing a random forest regressor, you could experiment with different parameters here. You could do a grid search CV or a random search CV, where you experiment with different max, depth, number of estimators, minimum sample split, things like that. There's different parameters that you could experiment with random forest. So that's one of the reasons why random forest is like really powerful compared to like linear models, because with random forest models, ensemble with tree-based models, there's many different options, many different parameters that you could tune. This is called hyper parameter tuning. There's different models, there's different parameters you could tune to, let's say, find the best combination for what you're doing. But in this case, I'm not going to tune anything. I'm just going to use the default. Just using the default random forest regressor. Like, I want to see what the score is going to be. And if I think it's worth my time, then I might tune it. So if the error that I get from a random forest regressor is lower than the linear model, then I might be interested in doing a grid search CV or random search CV to kind of tune the random forest regressor to see if I can get an even better score in this case, which is an even lower error. So I'm just going to use the default, and then for this RF, I already imported this. I don't need to import it again. I'm just gonna remove the mean. I'll leave the mean squared error here. Why not? Widespread R, because I just wanted to. I said widespread R because I want to have some differentiation between the linear model prediction and the some random forest prediction. I'll just run this for now and make sure there's no errors. Of course it's not. Let's go back here for a second. So if you're looking at a random forest regressor, right, let's see what parameters, let's see what method we have available to us. So the attribute it has is the estimator. So we can look at the number of estimators, the number of features, the number of outputs. Okay, so future importances, we are going to need that in a second. So these are the attributes that you can get. So I don't know if you guys noticed this. I mean, for me at this point it kind of seems like but whenever you have an sklearn model, so your sklearn models usually have attributes. So basically the attributes are the things that you could call up. Each call, like, this attribute is like after your model has ran, these are the things that you could extract from the model. So when you run something like a linear regression model, you could extract the coefficients, the rank, the intercept, and you saw me do that. Ooh, our mean absolute error score is lower, and our linear regression and our even our mean squared error is even lower. So our random forest model, just using like the absolute baseline, like not doing any hyperparameter tuning, not doing anything, has a better score than our linear regression model. That's good. That's good stuff. That's going to be, actually, that's really good. That could be like the beginning of our next, when I work on this project again next week, that will be kind of like the beginning of like, okay, could I do hyperparameter tuning on this random forest model to even get a lower score? Like, this is good stuff. This is some good stuff. And I'm excited already. Oh, hold on. That's not random. That's wrong. There we go. Let's do that again. And as you may have noticed, this is taking a little bit longer to run than. So this is good. This is good. So basically, back to what I was saying. So most scalar models come with attributes, and this attribute is what you can, pull out of it. So I pulled out like the intercept and the coefficients, right, from the linear regression model. So what we know is that a random forest model also has its own attributes that you could pull out. So in this case, it has base estimators, and all these other things that you could pull out. And in this case, I just want the future importances. Pulling out the future importances will allow me to create a visualization like this one. But before we get that, let's do oh yeah, we've already done our prediction. What am I talking about? And each model also has different methods. So basically, this regression model has apply, decision tree, fit. We already use the fit, and we already use the predict. But I'm not using the score. I could go back at any time and get to the scores if I wanted to use R2 score, as a measurement metric. And this measurement metrics is just a way for us to know how good or bad our model is. That's it. That's literally their job. So alright, so I want to pull out my future importances. So basically, if you click on it, to tell you a little bit more about future importances. But I'll just, let's say, future importances from random forest model. So we got our model RF model dot, I'll call it okay. So these are our future importances, from this model. But we are going to kind of like combine it with the column names and kind of create a visualization. So if we go back to this project that I did, sometimes I forget my own code, and I forget how to do something, and have to refer back to my own project in the past to kind of remember how I did something. So that's the ridge. Let's say decision tree model, random forest model. So I should have probably put in a random state there, but I think it has a default. Let me see real quick. Does it have a default random state? The default random state is none. So let me just go ahead and put that in there. And the random state, what it basically does is it makes sure that every time I run this code, I'll get the exact same result. That's like the simplest way to explain why we put in random states. Why the number 42? I don't know. I just that's what everybody else does, and that's what I do. Model forest, the future importances column. Oh, so basically it's the same thing like I did before. So basically there's nothing different. So to create the visualization, so let me put this here. So basically, this is just me. Let's see. Let's make sure I put it here. Uh, and I know I said I was going to end at 1 o'clock, but I think I'm almost done with today's project. So yeah, let me just go ahead and run this first, and then I don't need this because I already established it earlier. So my figures, okay, I'm just gonna leave it as 10 by 10, and I want this to be RF for random forest. Let's go ahead and run this. Alright, so this is our model future importances. So basically, this is like extremely similar to what we saw in the linear regression model, right? So basically, in the linear regression model, the way it does is it gives us like the ones that are having a positive impact and the ones that are having a negative impact, or like higher insurance premium, low insurance premium, stuff like that. But the way the random forest future importances work is that it um, it doesn't necessarily give us positive and negative. It just kind of give us the impact of each. So here it's telling us that all of this stuff down here, all of these features from agent all the way to special L1 doesn't have much impact on your insurance premium. Okay, like the ones that have like a ton of impact, what has a lot of impact on your insurance premium is the type of car that you have, and also your income has a little bit of impact, the month since last claim has a little bit of impact. But if you have a luxury XUV, luxury car, an SUV, the type of coverage you have, having a sports car, 2-door, 4-door, those things are the things that impact your insurance premium. So gender, income has a little bit of impact. Vehicle size, just a little bit of impact. Branch, number of open complaints, unemployment status, retired, personal auto, the state. Those things doesn't have much impact, on your insurance premium. I bet you if I analyze data just for the state of Washington, living in Seattle versus not living in Seattle is going to have a big impact on your insurance premium. Okay, like here in Seattle, the insurance premium cost is so freaking high. Like, I'm not kidding. But anyway, yeah. So, but anyway, let me go ahead and define the objectives for next year. I think this is like a good stopping point, right? Like this is what I think this is a good stopping point. Let's just put it that way. Let me just go ahead and comment this. Get add, get comment, message. Let's see. Random forest model done. Git push origin master. Alright. So basically this is like a good stopping point. Let me see if there's anything else I want to try. Let's see. think I may want to also create yeah I'll do model interpretation later. So these are just different model interpretation code that I wrote. So this is a type of model interpretation, more type of model interpretation technique. Future importances is just one type of model interpretation technique, but right now my main objective is not necessarily the best way to interpret the model. Right now I'm just focused on finding the best model to give me the lowest error, you know. So let me define my objectives moving forward, or even for next week in general. So I need to get it together. So basically object so my objectives moving forward is going to be something like, let's see, I want to hyperparameter tune random forest model to see if I can get a better and lower error score. Okay, that's one thing I want to do. Let's see. So I kind of know which features has the most impact, right? One thing I also wanted to do is well, if I'm going to put this online using Flask, I'm not going to put all the features online. I'm just going to have a model that just has one that just has the most important features, right? If I'm going to build a model where the users will input data and then get a prediction for the insurance premium, I'm not going to include all this other stuff that doesn't have great impact on the insurance premium. I'm only going to include these features in my model. So let me see. Let me see. Hyperparameter to random forest model to see if I can get a better and lower error score, and then build a linear regression model and random forest model for customer lifetime value objective. Remember, we had two objectives. We want to build a model for predicting the insurance premium. We also want to build a model for predicting the customer lifetime value. And then what else do I want to do here? And then let's say build different model interpretations for random forest models. Should I try other types of models? No. I want to hyperparameter tune the random forest model first and kind of see how low I can get that score, you know. The only thing, like at this point, this project is already a success because our models is performing better than the baseline, and our baseline error was like $25, and our linear regression model did 5 error, and then our random forest model did 4 as the error. So already the model is outperforming the baseline, and that's good. Okay, and then after this, after I've done building the model, so I want to, let's say, actually before I get to model interpretation, right, I want to, let's say, rebuild models for customer lifetime value prediction, and I want to rebuild models for customer lifetime prediction, and using the best features from this will allow me to have less features when creating model interpretation, and will allow me to have less features when we start building Flask app. And then my next step is to refactor my code and then figure out how to build a Flask app and put it online so that people can basically put in values for the important features we discovered and get a prediction for their insurance premium, and people can input values for futures and customer lifetime value, something like that. So this is kind of like my what I'm planning to do for it. So I want to hyperparameter tune the random forest model to see if I can get a better score. I may even want to do some feature engineering. No. How about let's see. No, I'm not gonna do any feature engineering. I'm just gonna leave it as it is. So I want to build a linear model and a random forest model for customer lifetime value objective, and I want to rebuild the models for customer lifetime value and the insurance premium, just using the best features. So basically in this case just using this first couple of features, and then I want to refactor my code, and then I want to build a Flask app where you can input different numbers and kind of see your prediction. And also I want to let's see, yeah, basically just put the project online so that when somebody, so I can give the URL to somebody and they can, see the project for themselves online without me giving them the notebook or the blog. Usually I write blog posts for my project, but and this time I want to build the Flask app for the project. I also want to, let's say, build a Plotly app for so basically this is like the next thing. So basically this project here, I wrote a blog post about it. So if you go to uh slash predicting, so if you go to this URL evidenceend.com slash predict life expectancy, you get my explanation of this project. But instead of just putting it in a blog post, I kind of want to also put it in a, I also want to put it online so that you can input different values and kind of get your life prediction, whatever, life expectancy prediction. So these are the kind of next kind of few projects I want to do. And basically these last two right here will really help me learn data engineering. It's going to help me learn how to build Flask app. It's going to help me learn how to build Plotly apps, so yeah. So that's basically it for this. Do you have any questions? It doesn't look like you all have any questions, which is perfectly fine with me. So that's it for this project. Thank you for coming to my TED Talk project. I'm just kidding. Seriously, thank you for being here and thank you for watching. If you have any questions, just let me know in the comment section. And you can always visit me online at machinelearningeducation.com. Here I have different free resources that you can grab for yourself if you wanted to. And you can also go to my website evidenceend.com and you can read my blogs at evidenceend.com/blog. And remember to subscribe to the YouTube channel and hit the bell icon so you get notifications when I make new videos. I mostly just teach software engineering, coding, data analysis. I enjoy it. Yeah, my content is mostly focused around coding and data analysis and a little bit of software engineering. So alright, I'm pretty much done with today's project, so I'm just going to exit everything. And to kill a Jupyter Lab session, you can go to File, Shut Down from here, or you can, if you opened your Jupyter Lab from Anaconda prompt like I did here, you can just click Control C or type in Control C, and that will shut down your kernels. And then you can click on Exit. And then when you come back here, you don't have to do it from here. It's already shut down from this. Yeah, so when I did a file shut down, it says error because I had already shut it down before. Just close that and we are done. And there doesn't seem to be any question, which is fine. So I'll just go ahead and end the live stream. Thank you for watching. If you have any questions, just let me know in the comment section, and I'll try to respond to my comments as soon as I see them. Thank you and goodbye.